Welcome to the lectures on problem solving and programming in C. This is the lecture 27 and the title of the lecture is sorting. So in many applications, as I told in the previous lecture, sorting and searching are fundamental problems in computer science. Many problems, many applications we require to sort data based on some values, and many occasions we need to use such procedures also. For examples, if ranks of students of in competitive examinations are displayed in, ranks are given based on their marks. So those who get highest marks will get a first rank. Okay, so this is one kind of a sorting problem. So let us see what are different sorting orders are there, and we will discuss one sorting algorithm called insertion sort. So sorting is basically arranging the elements in an order. Okay, what kind of order? There are four names for order of the data. One is ascending order. Ascending order means the the next element is definitely bigger than the current element. For example, you see here, 4 is bigger than 2, 6 is bigger than 4, 8 is bigger than 6, and so on. So this is a ascending order or increasing order. Increasing order. Descending order. Descending order means the next element will be smaller than the current element. 100, 90, 80, 79, 60. This is one descending order. Descending order is also called decreasing order. Non-increasing order. Non-increasing order. In these ascending or descending orders, we cannot have duplicate elements, because if there is a duplicate element, they will be coming together next to each other, and then that they will violate the property of ascending or descending order. So that is why we have different names. When there are duplicate elements, we have different names called non-increasing order. Non-increasing order means it's basically decreasing order, but then there can be duplicates. For example, 100, 90, 90 coming twice, right? And then 60 coming twice. So in this way, it is definitely decreasing. It's non-increasing. At least it may not be decreasing, but it's at least non-increasing. Non-increasing means the next element will be at least smaller or equal to the current element. For example, 100 is smaller than 90 is smaller than 100, and then 100 is equal to 90 is equal to 90, like that. Okay, this is a non-increasing order. Similarly, we can have a non-decreasing order. It is also similar to ascending order, but we have a duplicate element. Okay, so the next element is at least the current element, at least or more than the current element. So how do we sort the data? For example, so there are a variety of sorting algorithms. Suppose if you have given what is the sorting problem? What is the sorting problem? So sorting problem, problem. So what is the input sorting problem? Some numbers A1, A1, A2, and so on. Okay, AN. So what is the output? Suppose if you are talking about non-decreasing order, so we need to output numbers B1 less than or equal to B2 less than or equal to B3 and so on Bn, where Bi belongs to is equal to A for some, A is equal to AI for some AI. Okay. So for every element, we need to order the elements. For example, one input can be, so input, if you're talking about ascending order, let us say 100, 70, 20, 10, 50, 80. These are the numbers. What is the ascending order? Obviously, the minimum number coming first, right? 10, 20, and 50, 70, 80, 100. This is the ascending order or increasing order. Ascending order. How do you sort data? let us example. Let us take these same data. Let us see how we can sort data. 100. Suppose I will take one number by one number. So this process, whatever I'm going to discuss, the process is exactly the insertion sort process. Okay. How do we insert? So what I will take is I will take the first element. So first element, if you take A0 only, it is sorted. Only considering this element is sorted. So next what I will take is 100 and 70. I will take these two elements. 100 is already sorted. What is the, suppose if we consider 170, what is the correct position for 70? Correct position for 70 is actually first position, then 100 should come here. Okay. This way we did a swapping of the numbers. This is called swapping. 70 comes in place of 100, 100 comes in place of 70. This is called swapping of numbers. So we do sorting. Basically, sorting we use swapping algorithm, swapping process repeatedly to do the sorting of the numbers. So since suppose if we would consider the two numbers, what is the sorted order? 70, 100. Okay, next 20 comes. So what is the correct position for 20? So the correct position for 20 is basically 70. So we have to move like this: 70, 20, 100, and then 20, 70, 100. So we have to push this 20 to the right place. So insert this new number in a correct position. That is why it is called insert sort. Okay. Now you take 20, 70, 100, 20, 70, 100, 100. What is the next number? 10. So if you do swapping like this, what happens? So the correct 10 should come here, 20 should come here, 70 should come here, and 100 should come here. Next, suppose 10, 20, 70, 100. What is the next number? Next number is 50. 50. 50. What is the right place for 50? Where it should be inside? It should go here. We should swap numbers such that 50 reaches to its current position. So after swapping, what will be the numbers? 20, 70, sorry, 50, 70, 100. Okay. If we add another number, another number, I think, yeah, another number, next number is 80. If we add 80 here, what will be the right position for 80? So it should come here. So after this, so what will be the sort order? 10, 20, 50, 70, 80, 100. 100. Okay, this is sorted. So basically what it is at each iteration, so whenever basically we start for the first number. So when you take the first number itself, the number is sorted. When you take the second number, we try to see the where it fits in the sorted order, whether we need to swap with the previous number or not. So what happens is at each iteration I, okay, first A0, A1, and so on, A of I minus 1, they are already in sorted order. Sorted. This is sorted. Okay. Now we get a number, new number, AI. Okay. We just need to swap the numbers like this, so that AI is nicely inserted in its correct position, and at the end of the insertion, numbers A0 to A0, A1, and so on, AI are in sorted order, or in sorted order, sorted. Okay. So that is how it takes. Let us write the algorithm for the sorting algorithm. Algorithm. algorithm, insertion sort. So what is the input? Input, an array of n elements, n integers. Yes, where n greater than 0. Output, display the elements in sorted order, ascending order, basically ascending order, or increasing, non-decreasing order, non-decreasing order. There can be duplicates. Okay, right. Then begin. So what we will do is we will read the n value, number of elements, input n. So then there should be input validation if n less than or equal to 0, then output invalid input, and then stop. And if then otherwise what happens is we need to read the data, right? So for I equal to 0 to n minus 1, do input a of I, L of I. We need to declare L of n here, L of n declared, right? And for we have read n value and then validate the n value, and then after that we have read n numbers from the user. Now we need to call the sort procedure. Sort. So sort. Let us name this let us rename this to sorting. Algorithm is sorting. Okay. Then this procedure, let us name it a insertion sort. We are calling this procedure, okay, called insertion sort. Insertion sort. What we need to pass? We need to pass n value and list of n numbers. After that, we just need to display the numbers. For I equal to 0 to n minus 1, do output li and for. Okay, and so this function, what it does is it takes the list and rearranges the elements such that all the elements are in sorted order. After that, we are displaying the numbers, so the elements will be sorted. Let us try to write this procedure. Remember, it doesn't return anything. So it takes n and list and sorts them in L itself, and then doesn't return anything. Okay. Let us write this procedure. Insertion sort n and L 0 to n. Okay. Input n and L. Output sorts elements of L. That's it. It doesn't return anything. Returns nothing. Just sorts the elements. Okay. Begin. So we know that A0 element A0 itself sorted. One element array itself sorted. So we need to insert the elements from A1 to AN minus 1 in their correct position. So that is why for for I equal to 1 to n minus 1 loop. Okay. So what we need to do, we need to see, what we have is, we have something like this. So 0, 1, and so on, I minus 1. These are the elements, L0, L1 indices. Okay. First, what we need to do, we need to compare with Li with Li minus 1. Okay. So that is why j equal to I. While j, so j equal to I. So because we need to swap the elements, that is why we are using a different variable. While a of j is less than a of j minus 1. Okay. What happens if a of j is less than a minus 1? It means that the current element, so for suppose if we have 10 and here 20. Okay. So current element is smaller than the previous element. In that case, we need to swap these two elements, right? Swap these two elements. Okay. So t equal to ai. This is a swapping technique. We need a temporary variable to swap. A of I equal to a of I minus, sorry, it is j. A of j equal to a of j minus 1. A of j minus 1 is equal to t. Okay. After that, once these elements are saved, so 10 comes here, 20 comes here. Okay. What if there can be 18 here? There can be 18 here. Okay. So 10 may go further to the left side. So we need to compare a j minus 1 with the a j minus 2. So that's why we need to decrement j value, j equal to j minus 1. Okay. And y. What happens is, while checking like this, j value is decrementing, it may go out of index. Out of index means j value, if j value is 0, j minus 1 is minus 1. If j value is minus 1, j and j minus 1 will be minus 1. We cannot have a negative indices. So what is the valid value for j? J should be greater than 0 and aj less than. As long as this condition is true, it means that we need to swap the element, right? And for and, right? This is the function. So we are doing for elements 1 to n minus 1. For each element, we are doing a swapping of elements such that the elements rightly inserted in its correct position. Okay. After this iteration of I, A0 to L0 to Li are sorted out. Next, we will go for the next element. Okay. And then at the end of the procedure, all the elements are in nicely placed at the right place and the array is sorted. Okay. Since we are passing an array elements, you are changing the values of those array elements, automatically it will reflect the column. We don't need to return anything. So let us implement this in a C program. So cp, I'm using this listmax sorting.c. Sorting.c. There is a existing code we need, right? To read the n value and n value is red, l value is red. This is the code we need. So basically, we read n value, input validated n, then declared a list of size n, and then read these list elements. Okay. Then what you need to do, we need to call the insertion sort of n comma l. Right. After that, we need to display printf the array elements, right, in sorted order. Array elements after sorting. This is a message I am displaying so that user awares. So there is a for loop. Int I equal to 0, I less than n, I plus plus, printf %d comma L of I, right? After that, we need to implement this insertion sort. What it returns? It returns nothing, right? The function returns nothing. So that's why we have to say void insertion sort. If any function not returning anything, the return type should be declared as void. Okay. Int n, int l, right? Yeah. Now I'm writing this. So there is a for loop for int I equal to 1, I less than n, I plus plus. Then there is a int j equal to I, while there is a while loop. What is the condition in j greater than and a of j less than a of j minus 1. J greater than 0, and symbol is basically we have to use this, and this is the and symbol, right? L of j is less than L of j minus 1. I think I have written here a, this should be L. This should be L. This and this, 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 this. This should be L. Instead of A, we should use L here, right? Then there is swapping T equal to AJ. So int T is equal to A of J, L of J. L of J. Then L of J is equal to L of J minus 1. L of J minus 1 is equal to T. This is a technique to swap the element using a third variable. Okay. There are some other techniques also. So we just need to return from the function. We are not returning any value. We're just returning the control. Okay. And then this function should be declared. Prototype should be declared at the top. Okay. Let us compile the program. GCC sorting. It's compiled. Let us run the program. Number of elements, let us take 10, 20, 10, 30, 22, 20, 40, minus 10, 100, 200, 120. Yes, you see here 10, 20, 22, 20, 30, minus 10, 40, 100, 120. So there is an issue. There is an issue here. So what is happening is minus 10 is not sorted. Minus 10 is not sorted. Okay. So let us see why this is the case. Minus 10 is not sorted. Why minus 10 is not sorted? Oh, okay. So what is the issue is we have not included the statement j equal to j minus 1. That is the reason. J equal to j minus 1 we have not done. J equal to j minus minus we can do, right? J minus 1. If you see, only elements are only one step for one. See, the elements are only shifted by one element only, one level only. So they are not actually in sorted order. Okay, because 20 is coming after 22. So let us compile and run with the same data and see. So 20, 10, 20, 10, 30, 22, 20, 40, minus 10, 100, 200, 120. Okay, I give the same data. Now you see the elements are nicely displayed in a non-decreasing order or increasing descending order. Okay, non-decreasing order because there are duplicate elements in the repeated elements in the array. So this is what insertion sort is all about. Okay, insertion sort. The function is called here. So we read the number of elements n, validated, declared a list of size n, integer array of size n. Then we have read the elements. Then we call the function insertion sort. Then after that, we have displayed the array elements which are already sorted through the function called insertion sort. Okay. So like this, there are many in sorting techniques like bubble sort, selection sort, merge sort, quick sort, um, like that. There are many sorting algorithms. So for to know what is sorting and how sorting algorithm works, so in this course we have included only one sorting algorithm called insertion sort. Okay. Thank you. We'll continue the discussion. Thank you.